This is a lesson for 4.1. Our objectives for today is the student will be able to identify polynomial functions and graph polynomial functions using the table and the in behavior. So a couple of terms that you'll need to know. Some of these hopefully are familiar. A polynomial is simply a monomial or a sum of monomials. Now, this goes back, you should have got this in Algebra 1, but a monomial is, mono means one and nomial means term, so an example of a monomial could be 4xyz. Now, terms are separated by addition or subtraction signs. I know it says sum, but remember, a subtraction can become addition, you add the opposite. So we could do this, and that would become two terms because we have that addition sign. Even though we've used the same numbers and letters, it's now a two-term or binomial. And now I could change it into three terms using the same number and the same variables, but again, addition and subtraction signs separate terms. So 4x is a monomial, y is a monomial, and z is a monomial. And so this polynomial would, since it has three terms, would be called a trinomial. If we get more than three terms, again, let's use the same number and the same letters. But now we have four terms, so four monomials that are added or subtracted from each other. And anything over three terms, so a single term is a monomial, two is binomial, three is trinomial. Anything more than that, they'll just say a four-term polynomial, or if there's five terms, a five-term polynomial, and so on. Now, a polynomial function, this is the way it's written in the book, I wouldn't worry about this, is a function of the form. So what they've done is use letters to write everything. But let's do it with numbers. Let's say we have so this is a four-term polynomial. Standard form is when it's written from the highest exponent to the lowest exponent, and the constant is always last. And so you can see this goes from x to the third, x to the second, x to the first, and 5, so that would be in standard form. Some terms that you're going to need to know, we covered this earlier in the year, but the term that has the highest degree. So this x to the third, the highest degree is, or the highest power is 3, and that's what the degree is. The degree is the highest exponent that we have. So in this case, this would have a degree of 3. The leading coefficient, coefficients, remember, are numbers multiplied to variables. So if I have 5x, 5 is the coefficient, x is the variable. So any number multiplied to a variable is called the coefficient. The leading coefficient, if it is in standard form, is the first number that we see. So in this case, our leading coefficient would be 4. And the constant is always a number by itself, so the constant in this case would be 5. And so we get 4x to the third. Again, find the highest degree. Now, if it's not in standard form, we can put it in standard form. But let's say we had something like that. I don't need to put it in standard form to find these things. Again, the degree is the highest power. And so the degree in this case would be 5. The leading coefficient is not necessarily the first number, it's the, if we put it in standard form, it's the first coefficient. But it's always the coefficient of the term with the highest degree. And so the leading coefficient would be 12, and then the constant would be 7. So, here's things that make it not a polynomial function. So things that we look for that will make it so we wouldn't say it's a polynomial function. And the things that you'll notice are a negative exponent. So an example I have here is x to the negative 5th power. If that exponent is a negative number, then it is considered to be not a polynomial function. If I have a variable in the denominator, example would be 1 over x, where the variable's in the denominator. And these are really tied together because, again, back from when you hopefully were introduced to negative exponents, and if you haven't been, a negative exponent just moves it opposite where it's located. So this actually becomes 1 over x to the 5th. So a negative power sends it opposite where it's located. So these are really the same thing, just written differently. And then if you have a variable in the exponent, so like in this case we have 3 to the x or 5 to the y, it doesn't make any difference. If I have a variable in the exponent, then it's not a polynomial function. So if we look at the textbook on page 158, this is kind of a chart that gives us some of the terminology. The main things you're concerned with, these are just examples and then examples that are done in variables. What you need to know for the assignment is these terms. That if we have a constant, just a number, like negative 14, remember the degree is the exponent. We don't have a variable here, and so we don't have an exponent. Now, you do have to remember this. If I have x, and there's no power, it's to the first, so that degree would be 1. But with a constant, the degree is 0, and the reason for that is, if I take x to the 0 power, anything to the 0 power is equal to 1. The reason that occurs is this. Remember when you multiply variables, you add the exponent, so that would be x to the 5th, because we have 3x's times 2x's gives us 5x's. If we're dividing, remember, with multiplication we add powers, with division we subtract powers, and so that would be x to the 3rd because 5 minus 2 is 3. Well, if we continue that rule, x to the 5th divided by x to the 5th would be x to the 0. But you know from basic math that anything divided by itself is equal to 1, and so x to the 0, that's why it's equal to 1. So, if we just have a constant, the degree is 0, and the type is constant. If it's to the first power, 5x is to the first power, so that would be degree 1, and that would be a type would be linear. If the degree is 2, it's a quadratic. Degree is 3, it's cubic. Degree 4, quartic, and you're not going to have any powers higher than 4 that they're going to ask you for. So 5 would be quintic and so on, but you're not going to have to do that. So here's what they're going to ask you to do on the assignment. If we look at this. So, it asks us to decide whether each function is a polynomial function, and then if so, write in standard form and state its degree and the type and the leading coefficient. So what we're looking for to decide if it's a polynomial function is those things that make it not a polynomial function. And so all our exponents are positive numbers. We don't have any variables in the denominator, and we don't have any variables in the exponents. So this would be a polynomial function, and then it already is in standard form because it's highest to lowest power. And so the degree would be 3. The leading coefficient would be -2, because number multiplied x to the 3rd. And the type, since it's degree 3, would be cubic. And so that's what they're going to ask you to do on these. So if we look at this one, x is to the 3rd, x to the 4th, -12. So we're okay. We can have numbers that have square roots, and we can have decimals, but it's not in standard form. So to put this one in standard form, I would rewrite it. Now I will tell you when you do this on the computer, if you're doing on the computer the assignment, you have to make sure you put that x to the 4th outside. If you just type the square root and then 2 and then type in x to the 4th, it will put it underneath the square root sign and make your answer wrong. Minus 0.8 x to the 3rd minus 12. So that would be standard form. The degree would be 4. The type would be, quartic. and the leading coefficient would be the square root of 2. If we go to the third one, we have a negative power, so that would be not a polynomial function, so then you don't have to do anything else. And then here on this one, again, we have a variable in the exponent, so that would not be a polynomial function also, and so you wouldn't have to do anything on that one. So let's look. So just a few more examples. So again, to put this in standard form, we would make the negative 1.6x squared first, minus 5x plus 7. Then the degree would be 2, the type would be quadratic, and the leading coefficient would be negative 1.6. Here again we have the negative power, so not a polynomial function. Here we're okay, so again, to put it in standard form, 3x to the fourth plus x to the third minus 6x. Now we don't have a constant shown here, but the constant would be 0 if they ask you for it. So our degree would be 4, our type would be quartic, and our leading coefficient would be 3. So those hopefully are fairly easy for you. So if we go on, the next thing we're going to talk about is in behavior. What the graph does is it approaches positive infinity, which means as it goes to the right. So if we have a graph here, what we're talking about as it approaches positive infinity, remember these are our positive numbers of x to this way. And so positive infinity would be as I go to the right. And negative numbers are here, so as I go to the left, that would be negative infinity. So what we're going to do is talk about what happens to a graph as we look at it at both ends. So this graph can do a lot of things. But we're going to talk about what it does as it goes to the right and what does it do as it goes to the left. So as you can see here, this one finishes going to the right, going down. And so the way I would write this is as x approaches positive infinity, f of x, which is the graph, approaches negative infinity because it's going down. And then to this side, as x approaches negative infinity, so as it goes to the left, the graph is doing what? It's going up, so it's approaching positive infinity. So this is how it can be written. I will tell you the textbook does it in reverse. They'll put f of x approaches negative infinity as x approaches positive infinity. So they're just going to say the graph is going down as the x values go to the right. And this would say f of x is approaching positive infinity, so it's going up as x goes to the left. So I don't care which way you write it, but on the computer they'll do it in reverse order. So if we look in the textbook, they have this chart on page 159 of the textbook. And they go through the in behavior, and they go through it in the 4 types that we can have. So a graph can be going up to the right and down to the left, or it could be going up to the left and down to the right, or it could be going up at both ends, or it could be going down at both ends. And so those are the only 4 types you can get. But the key is we look here at the degree and the leading coefficient. So in this case, because the degree is odd and the leading coefficient is positive, our graph would look like this. And so our answer would always be, as x approaches positive infinity, goes to the right, the graph goes up. And as x approaches negative infinity, f of x, the graph goes down. If it's odd and negative, it's going to be reverse. If it's even and positive, they're going to both go up to the right. So the graph goes up as we go to the right, and the graph goes up as we go to the left. Or it could be even and a negative coefficient, and then that means the graph goes down at both ends. And so, again, as the graph goes to negative infinity, it's going x as we go to the right, and the graph is going to negative infinity also as we go to the left. So this is one thing. You can always just look at the equation. So like if I look at this equation here, all I do is I look at the term with the highest degree. And in this case, the degree is 4, which is an even number, and the leading coefficient is negative. And so I go even, negative, so I would be able to write my answers like this. Or again, I would write it as x approaches positive infinity, f of x goes to negative infinity. And as x approaches negative infinity, f of x goes to negative infinity. You can do it again either way. The textbook won't give you, or the computer won't give you the options. You'll have to select the way they did it, which would be this way. Now, it's fine if you want to use the chart. If you just want to use some other notes, here's how I do the in behavior when I try and decide how it works. So in this case, the in behavior, I look at the leading coefficient first. And I have two choices. It's either positive or negative. If it's positive, my graph will always go up to the right. And if it's negative, the graph will always go down as it goes to the right. Then I look at the degree. And if the degree is even, then both ends will go the same direction. And if the degree is odd, it will always go in opposite directions. So, if we, as an example, it doesn't, again, this term, they can have as many terms as they want, it doesn't make any difference. I just have to find the term with the largest degree. So, whatever that is, I just find that term that has the highest degree, and that's the only thing I need to look at. So the first thing I ask myself is leading coefficient. Is it positive or negative? In this case, it's positive. That tells me it's going up to the right. So when I go to write these answers, if I do it, so I look at the graph, and I can write, this is the answer I'm looking for. All I have to do is fill in the last part. What's the graph doing? So this says as x goes to the right, what's the graph doing? And as x goes to the left, what is the graph doing? So because the leading coefficient is positive, I know it's going up to the right, so it's going to finish going to positive infinity. And then I look at the degree, and since the degree is an odd number, if the degree is odd, they go in the opposite direction. So since this was going positive, the opposite would be negative. So, again, with every problem, I'm going to write this as the answer. So again, if my highest term was, let's say, negative 12x to the 14th, well, it's negative. Negative tells me it's going down to the right, so it's going to negative infinity. And it's even, which tells me it's going the same direction. And since that's going to negative, this is also going to negative infinity. So I know it's going down at both ends. And so I like to use this, but if the chart's easier for you to look at and find the answer, that is fine. So if we look at example number 3, so as we look at example number 3 here, again, the only thing I care about is this term with the highest degree, so this x to the 4th. So again, I can use the chart. The chart says that it's negative and an even, and so negative leading coefficient and even power would be here, so I would know the graph is going down as it goes to the right, the graph is going down as it goes to the left. So I could write it this way, or again, you can write it as x approaches positive infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x approaches negative. Or you can use the notes that I give, which tells me, hey, it's negative, so I'm going to write as x approaches positive infinity, f of x does what? And as x approaches negative infinity, f of x does what? So it's negative, so that tells me it goes down to the right, so negative infinity. And it's an even power, so that means it's going the same direction, so it's also going to negative infinity. So again, it's totally up to you which you would rather use. So it doesn't make any difference. The last thing that they're going to ask you to do is to graph a polynomial function. And to do that, you want to plot points to determine the middle portion of the graph, so what it's doing in between. And then use what you know about in behavior to sketch the graph. So the easiest way to do this is just to look at an example. So if I give you 3x to the third minus 2x squared plus 2x minus 5, and I ask you to graph that. Now, I can make up my own table, but it's fine to go to the Desmos calculator and type it in and hit table and have it printed out for you. But I can also do it by hand, plug in. All I'm trying to do is get numbers, so I know, because this is positive, it goes up to the right, and it's odd, it goes down to the left. So I know my graph's going to end up going down to the left and up to the right. So what I'm looking for is for numbers to start going up and then numbers to start going down, so I can just plot this graph. So I'm going to plug in 1. 1 would be 1, that'd be 3. Minus 2 would be 1. Plus 2 would be 3. Minus 5 would be a negative 2. Now I'm going to plug in 2. That would be 8. That'd be 24. Minus 8 would be 16. Plus 4 would be 20. So there it starts going up. So now I need to find out when it starts dropping off. So I plug in negative 1. That would give me negative 3. That would be minus 2. Minus 2. Minus 5. So that would be minus 12. So I probably got enough to draw this graph. So it's 0. So all I need is enough information to know that at 0 I'm at negative 5, so approximately there. At 1 I'm at negative 2. At 2 I've now skyrocketed up, and at negative 1 I've started going down. So my graph is going to look something like this. So you don't need exact numbers. You can just get approximations. And you just need, so again, you can plug in the numbers, or again, you can go to the Desmos calculator. When you go to the Desmos calculator, here, let me run that up here. So if we put that function I just had back in, 3x squared minus 3x cubed, x 3x cubed minus 2x squared plus 2x minus 5. So we have that in there. If I go to settings, I can just hit table, and you can see that I have the same values that I had, but it's just a quick way to get those enough values that I can see what the graph does. And so you can see here what this graph is doing. But again, it's finishing up to the right and down to the left. So that's all you have to do on that. So your assignment is page 162, numbers 3 to 31, the odds. Again, that's on the computer. If you go to that, it's 4.1. Hopefully that will take care of it.